All right, welcome back. So we've talked about how artificial intelligence is the big dream of making machines smart, and machine learning is the way we usually do it. You know, kind of like teaching a computer with flashcards.
But what happens when the problem isn't so neat and tidy? What if the task is really, really complicated? I mean, we're moving beyond simple flashcards and into the real world with all its chaos and, well, messiness.
For instance, a simple flashcard system can get pretty good at telling a cat from a dog. No problem. But what about identifying a specific breed, like a Siberian Husky that's halfway hidden in a snowstorm, and you're looking at it from some bizarre angle? Yeah, that is a whole other level of difficulty. A simple flashcard system is going to have a real hard time with that.
For these super complex problems, you need a much more powerful tool. And this is exactly where deep learning comes in. This is the engine behind some of the most mind-blowing AI that we see all around us today.
So, what's the easiest way to get your head around it? Well, if machine learning is like one person studying flashcards, deep learning is like giving that person an entire office building, staffed with a massive, highly specialized team, all working together on the problem.
So, let's actually build this team. Let's say our goal is to make an AI that can look at any photo and tell us exactly what's going on. To do that, we're going to organize our team of experts into different layers, on different floors of this building.
See, each floor has a totally unique job, and they pass their findings up to the next level. This whole layered approach, well, that's the secret sauce to deep learning's power. So let's start our tour on the ground floor.
Okay, so on the ground floor, we have our pixel detectives. Their only job, and I mean their only job, is to look at the image and report on the most basic things they see. They don't know what a dog is, they just find the simplest building blocks imaginable.
And their reports are incredibly simple, just like you see here. They're just shouting things out like, "Hey, I see a straight line," or "Found a red pixel over here," or "There's a curve in this spot." They have no idea what any of it means. They just identify these basic bits and pass them upstairs.
Now on the second floor, we've got our shape analysts. They take all those little reports about lines and curves and colors, they see a bunch of them together, and they say, aha, based on all these simple shapes, I think what I'm looking at here is an eye, or maybe a nose, or what looks an awful lot like furry texture. They're combining those simple features into more meaningful parts.
Okay, now we go up to the third floor, to the object experts. They get the reports from the shape analysts. They see two eyes, a nose, some floppy ears, and a wet snout, and they put it all together. Their conclusion? This whole combination of parts, that's a dog's face. They're assembling the parts into a whole, recognizable object.
And finally, on the top floor, in the penthouse suite, we have the director. The director gets all these high-level reports from the floors below, things like dog's face, park background, frisbee, and puts it all into context to make the final, confident call. The director says, this is a golden retriever playing in a park. This entire process, this multi-layered, bottom-up system, that is the essence of deep learning.
So, our office building analogy is a great way to picture the process. But why do we actually call it deep learning? Let's connect that analogy to the real tech and see what makes this structure so incredibly powerful. The deep part, it's actually pretty straightforward. It just means having many of these layers. Technically, they're called neural networks. Each layer, or each floor in our building, learns to recognize patterns at a different level of abstraction, from the simplest pixels all the way up to complex real-world objects.
But here is the most powerful, the most mind-blowing part of all. The system learns this entire hierarchy of features, from pixels to noses to entire dog faces, all by itself. We don't have to tell it, hey, go look for an eye. By analyzing millions and millions of images, it figures out on its own that an eye is a super important feature to look for to get to its final answer. It teaches itself.
And this ability to learn automatically is exactly what allows deep learning to do things that, not too long ago, we thought were impossible for computers. And you know what? You're already using it every single day.
When Google Photos magically recognizes your friends and pictures you haven't even tagged, that's deep learning. When a self-driving car spots pedestrians, other cars, and traffic signs in real time, yep, that's deep learning. And when Google Translate understands the context of a sentence to give you a really natural translation, not just a clunky word-for-word one, you guessed it, that's deep learning too.
Okay, so let's zoom out and put this all together. Let's get this AI family tree straight, once and for all. So here's the simplest way to think about it. Artificial intelligence is the big dream of smart machines. Machine learning is the most common method we use to try and make that dream a reality. And deep learning? That's the supercharged, most advanced, most powerful version of that method, using all those deep layers to solve incredibly complex problems.
This layered, self-teaching approach is the fundamental reason that AI can do things today that truly felt like something straight out of science fiction just a decade ago. It's just a massive, massive leap forward in what machines are capable of.
So now you know the what behind modern AI. You understand the big ideas. Are you ready to explore the how? Because in our next explainer, we're going to dive into the different styles of machine learning that power these amazing systems. See you then!